Imagine buildings that grow stronger on their own, and clean the air like trees. This isn't science fiction, it's happening right now with living materials. Let's explore how. In a groundbreaking leap towards sustainable architecture, researchers have developed a photosynthetic living material, a futuristic gel-like substance that could literally help buildings breathe. Made from a combination of blue-green algae, cyanobacteria, water, sunlight, and carbon dioxide, this material functions just like a plant. It grows, heals itself, and even absorbs CO2 from the air. But this living material isn't just about mimicking nature, it outperforms it in many ways. By embedding the algae in a 3D printable hydrogel filled with microscopic pores, scientists have created a structure that allows light and air to reach the algae, maximizing photosynthesis. What makes it so powerful? Here's where it gets exciting. The gel doesn't just store carbon inside the bacteria. With the right added nutrients like calcium and magnesium, the carbon dioxide gets converted into solid minerals like limestone. That means, the material becomes stronger over time. The captured carbon is locked away permanently. It essentially turns the gel into a kind of self-healing bioconcrete. This is a major game changer. During tests, this material continuously absorbed about 26 milligrams of CO per gram over the span of a year, making it far more efficient than traditional carbon capture methods. Real-world applications, building with biology. At a recent architecture show in Venice, scientists showcased designs resembling tree trunks made from this living gel. These structures could potentially absorb as much CO2 per year as a 20-year-old pine tree, but without needing soil, roots, or pruning. Researchers believe future versions of this material could be used as coatings on urban buildings, shaped into modular designs for smart cities, integrated into walls, rooftops, and ventilation systems. Imagine your city not only emitting less carbon, but actively absorbing it just by existing. How it works. 1. Photosynthesis. The cyanobacteria inside the gel absorbs CO2 using sunlight. 2. Storage. At first, the carbon is stored within the bacteria's own structure. 3. Mineralization. Given the right nutrients, the carbon turns into hard minerals. 4. Strengthening. These minerals form a skeletal frame, making the material more durable, like concrete that grows. Over time, this cycle turns the soft gel into a resilient, self-sustaining material, perfect for real-world use. What challenges remain? Of course, it's not without hurdles. One big question is, how do we keep the algae alive once the material is used on buildings? Scientists are now working on nutrient delivery systems, sunlight optimization through smart windows, ways to boost carbon absorption efficiency. They're also experimenting with different strains of algae to find ones that are even better at capturing carbon in urban environments. Why this matters, especially in Europe. Europe has been leading the charge on climate-neutral architecture, from Scandinavian timber towers to Dutch floating homes. This living material could become a key part of Europe's Green Deal goals and help cities become climate positive by 2050. Instead of building concrete jungles, we might soon live in biological cities, where homes, offices, and public buildings act as carbon sinks, not just carbon sources. This could redefine how we think about construction, sustainability, and urban planning. If you're fascinated by the idea of buildings that grow and fight climate change, then hit subscribe button for more science and tech breakthroughs. Like the video if you support sustainable cities. Comment below, would you live in a house made of living material? Share this with someone passionate about green architecture.